Hi, I am Akhilesh Kumar Srivastava from ABES Engineering College, Ghaziabad. In today's lecture, I am going to discuss a problem at the Codechef platform named as minimum coloring. Now, let's look at the problem statement. So here is the problem which says that a matrix of size n cross m has been given to us. Two distinct cells of the matrix are colored with the color number 1 and 2 respectively. You have to paint the remaining cells of the matrix such that no two adjacent cells are painted with the same color. So here it is saying that a matrix is given, and in this matrix, the two cells are already colored with the two different colors, 1 and 2. You have to find out that how many minimum colors are required to paint the remaining cells of the matrix such that no two adjacent matrix is colored with the same color. To understand this problem, let's see a scenario. Suppose we have a chessboard. In that chessboard, you require only two colors to color the cells. For example, you can see this chessboard on the left hand side. And in this chessboard, you can see that if I color this cell with 1, then this cell should be colored with two colors. If I color this cell with 1, then next cell should be colored with the 2 cell. If I pick any random cell, for example, this one, the surrounding cells or the adjacent cells will be these. And you can see that the adjacent cells are not in the same color, but they are in the different colors. But I require only two colors to color the cells of this chessboard. So we will employ the same fundamental here for solving this question. Now suppose we are assigning the row number and the column number to a chessboard or to a matrix. And then we are going to note down the sum of the row and the column. So sum of the row and the column is 2 here. It is 3 here, 1 plus 3, 4 here, 1 plus 4, 5 here, 1 plus 5, 6 here, 1 plus 6, 7 here. So in the similar fashion, I'm going to write down all the cells with the sum of the row and the column values. So having done the sum of the row and the column for each of the cell, if you identify any of the cell, let's say we are picking up the 6, you can see that 6 is the even number and the surrounding or the adjacent cells are these ones and these are the odd numbers. So if I select the if I select the even cell, then the surrounding cells will be odd. And if I pick any odd number, let's say this one is the odd cell selected, the surrounding or the adjacent cells of this will be in even number. So this is also the observation that if I select the odd cell, then the surrounding cells will be even. If I have no constraint, I can allow all the even cells to have one color and all the odd cells to have another color. So if I obtain the coloring scheme from this matrix to this one, so I assign one color to the even cell and two color to the odd cell. One to even, two to odd, one to even, two to odd, two to odd, one to even. So likewise, we are painting the different cells based on if the sum of the row and the column is odd or they are even. In this way, no two adjacent cells have the same color. Now, if I look at the problem, the actual problem statement is saying that there are two test cases, let's say. In that two test case, the size of the matrix is 2 cross 2. The first matrix has 2 cross 2 size, and its cell number 1, 1 has been colored with number 1, and cell number 2, 2 have been colored with color number 2. In the second test case, the size of the matrix is 2 cross 3, and the cell number 1, 1 has been colored with color number 1, and cell number 1, 2 has been colored with color number 2. To solve this problem, I will first take the, I will first take the second test case, because second test case is going to be easy one for us. So I'm trying to solve the second test case first. So the second test case is saying that we have a 2 cross 3 cell or 2 cross 3 matrix. In the 2 cross 3 matrix, there are 2 rows and the 3 columns. If I number the row and the columns like this, the 1 1 cell has been colored with color number 1 and 1 2 cell has been colored with color number 2. So if I add the row and the column numbers, add the row and the column numbers, I obtain 2 here. If I add row and the column number, I obtain 3 here. So you can see that the even number cell has been colored with color number 1 and the odd number cell has been colored with color number 2. So in this case, I require only 2 colors because the scheme that we were suggesting here is actually being followed here, that the even cell is colored with one number and the odd number cell is colored with a different number. So we will employ the similar mechanism to color the remaining cells. For example, I obtain the sum of the row and the column 4 here. I obtain it 3 here, 4 here, and 5 here. So the odd number cell has been colored with, even number cell is colored with color number 1. So I give a color 1 here. Odd number cell is given a color number 2. So I write 2 here. Similarly, 1 here and 2 here. So the colors have been assigned to the different cells of this matrix and you require only 2 colors. Suppose we are taking up this test case. So this test case is saying that we have a 2 cross 2 matrix and cell number 1 1 have been assigned a color 1 and cell number 2 2 have been assigned a color 2. So if I write the row number and the column number here, if I add these two values, the row and the column values, I obtain 2 here, I obtain 3 here, I obtain 4, I obtain 3 here, and I obtain 4 here. So you can see that the even cell 2 and even cell 4 are colored with the 2 different colors. So this actually fails our logic because we have selected that the even cells will be colored with one color and the odd cells will be colored with a different color. So what we can do here, that we can assign the third color to the adjacent of even cells starting from 1. So I can assign a color 3 and I can assign a color 3. So this way the adjacent cells are colored with the different colors. So what scheme we are actually following, that if we obtain that the 2 cells which are given to us are colored with the with a different color, even if they are their row and the column sums are even, we can assign the third color to paint the different cells. Let's take a bigger example that will actually make us understand this problem in a better way. So let's say we are taking this one. Now, if it is being said that the cell number 2 2 have been assigned a color 1 and cell number 4 and 6 that is assigned with the color 2. Okay, so if these 2 cells have been assigned a color, you can see that 2 2 cell is summing up the value 4 and the 4 6 is summing up the value 10. So both are even then they are assigned the different color. So what you can do that, you start from here and you either assign a color 1 or you assign a color 3. So if you obtain an even cell, you assign a 1 color, and if you find out the odd cell, you assign color number 3. So the sum here will be 2, here will be 3, here will be 4, 5, 6, 7. So this is giving us some hint about the row sum and the column sum. Let's assign the colors. So let's say we are assigning the color to the even cell as 1 and to odd cell we are assigning the color 3. So 1, 3, 1, 3. This is odd, so assign a color 3. This is even, this is odd, assign a color 3. Even, assign a color 1, 3, 1. So 1, 3, 1, 3, 1, 3. This one will be 3, 1, 3, 1, 3, and then 1, 3, 1, 3, 1, 3. So if you have frozen the color number 2 and you assign the color 1 and the 3 to the different cells, you are actually obtaining the minimum colors to color the different cells. So in this case, the total number of colors required are 3. So the logic that we have built here is that if the two cells given to us, or the two cells which are whose color have been frozen, one of them is even and the other one is odd, so we will apply the same scheme as the chessboard. But if both are odd or both are even, in that case, we will assign a third color. So we will freeze the color number 2 and we will assign color number 1 or color number 3 based on if that is odd or this row and the column sums are even or they are odd. So now let's solve this problem at the Codechef platform. So see, in this problem, when the test cases are given, it has been specified that the first row and the first column is 1, 1. It means that if you are solving it in any of the language, then we will be finding that the first row and the first columns are denoted by 0 and 0. But here it is 1 and 1. So it means that we will have to make a matrix of size R plus 1 and C plus 1. So we are taking the input of the number of rows and the number of columns from the user. And then we are making a matrix or creating a matrix of size R plus 1 and cross C plus 1. And we are assigning all the cells as the 0 value. Meaning of the 0 value or the initial 0 value means that there is no color assigned to these cells. So x1 and y1 are the coordinates of the first cell, which is painted in color number 1, and x2 and y2 is the cell which is painted in color number 2. Let's take the input x1 y1 coordinate and x2 y2 coordinate. Let's try to find out if these if the x1 plus y1 and x2 plus y2 is even or odd. So this is c1 and this is c2. If both are different, it means c1 and c2 both are different, it means one is odd and the other one is even. In that case, we will apply the same scheme. If c1 is 0, we take two colors, color 1 and color 2. Color 1 is assigned as 1 and the color 2 is assigned as 2. Otherwise, the reverse. The color 1 is 2 and color 2 is 1. Now we have to paint the remaining cells. So to paint the remaining cells, we will look at every cell in the matrix. So for from I equals to 1 to R, and then nested loop with the j equals to 1 to C. It means that we will look at every cell and we will assign a color to that. So if the row sum is even, we are assigning a color 1. If row and the column sum is even, we are assigning a color 1. And if that is odd, we are assigning the color 2. So this was the case when the two cells given to us were even and odd, or odd and even. But what if they are not even and odd? They're either odd or they are even. So we are looking at this condition here. So what we are going to see that we are assigning the colors. It means that mx1 y1 and mx2 y2 have been assigned with color number 1 and 2. Then we are identifying if this x1 plus y1 is even or odd. So for doing that, we are finding out the modulus of x1 plus y1 mod 2 and storing it in C. So C will store either 1 or 0. Now having done this, we will paint a different color. Okay. So if we are taking the matrix and we will look at every cell with the nested loop. So if mij is not equal to 2, meaning that this does not have the color 2. So if the color has already been assigned to a cell which is 2, we are not going to look at that. But for rest of the cells, we will assign a color 1 or 3. So if I plus j mod 2 means we are checking if this is even, or this is equal to C means if C is 0, so I plus j modulus 2 is also 0. It means that x1 plus y1 was the even number. And if C is 1, it means that x1 plus y1 is the odd number. So if I plus j mod 2 is also odd number, then we will assign it color 1. Otherwise, I will assign the color 3. So I'm just looking at the nature depending on the input of x1 and y1. So if the nature matches, we are assigning the color 1. And if the nature does not match, we will assign the color 3. So this way we can paint the different cells of the matrix with the 3 different colors. Now, ultimately, we have to print this. So for printing this, we again go to the nested loop. And in the nested loop, I'm going to print this matrix. Fine. Here in this problem, it has also been given that there are multiple test cases. So in the main, we are taking the input C, input T. The input T is the number of the test cases. For every test case, we will call the matrix color function that we have designed here, and it will paint the different cells and will print. So now let's try to compile and run this program. So after compiling, you can see that the sample test cases have passed. Now we will submit this. You can check that all the test cases have passed. Thank you.